Today we're going to look at graphing inequalities. So let's go ahead and get our notes out and we'll get going. During any point in the video, if you are falling behind, remember to pause the video and get your notes caught back up. Or if you didn't quite understand something the first time, stop the video and listen to that piece again. Sometimes it takes a couple times through to get the concept down. Okay, let's go ahead and begin. We are looking to graph the inequality y is less than 2x plus 1. And the first thing I notice is this is linear, so I know kind of the shape. And when we think about graphing in general, graphing is just a picture of our solutions. So if we are graphing an equation, and that's one with an equal sign, the line, or the points on the line, or the points that make up the line, are our solutions. When we're graphing an inequality, we don't just have a line, but we have a whole area of answers. So let's go ahead and see what that area looks like. All right, since we have an area of answers, the first thing we want to look at is the boundary line. The line that separates our solutions from our non-solutions, our answers from our non-answers. So to do that, we're going to look at our equation, and we're going to graph it as if it had an equal sign. All right, so the first thing I notice about this linear equation is it is in slope-intercept form, and that's simply y is equal to mx plus b. So I'll go ahead and write that up here. Now we could also use a chart, plug in an x and get a y and do the same thing. But I'm going to go ahead and review this form where m is our slope and b is our y-intercept. So if I go to our equation, I can see my slope is simply 2. And remember, slope is rise over run, so I'm just going to go ahead and put that 2 over 1, where my rise is 2 and my run is 1. Or my vertical change is 2 and my horizontal change is 1. Now my y-intercept, the b, is simply at 1, and that's the point. X is 0, y is 1. That's our y-intercept. So I'm going to take these points, or this point and the slope, and come over and graph this line. So here I am on my y-axis, and at the point 0, 1, there he is. I'm going to use my slope of 2 over 1, so that's 1, 2 up, and 1 over. There's my second point. And for good measure, I'm going to put a third point in. So again, 2 up, 1 over, that's using my slope. I now have enough to make my boundary line. All right, the next thing I notice is that this inequality is a less than, and a less than implies we're going to connect the dots, or the boundary lines, with a dotted line. So I'm going to come over here and I'm going to go, okay, so my boundary line is dotted. And the significance of the dotted line implies that our solutions on the line, or our points on the line, sorry, not solutions, the points on the line are not solutions. Okay, so once again, this implies points on the line are not solution. Okay, so what that means is our solutions come right up to the line, but not on the line. All right, so we graphed our points. We connected with the dotted line because it's less than, meaning the points on the line are not solutions. And lastly, we have to shade. Let's talk about shading a little bit. And when we shade, we're saying the shaded region equals our solutions. Those are the area, or it is the area where all our solutions exist. So to find the solutions, we're going to use a test point. So what we're going to do is we're going to pick any point away from our line. My favorite point is 0, 0. I'm going to pick this point right here because the math is easy. But you could pick a point up here or down here. It does not matter. And we're going to take our test point, 0, 0, and we're simply going to substitute in an equation and see if it's true or false. So we have y is less than 2x plus 1, or in this case our y is 0, times 2 times our x, which is also 0, plus 1, which simplified is 0 is less than 1. Since 0 actually is less than 1, we shade, or solutions lie on that side with that point. Since this point is a solution, so are all the other points on this side. So rather than scribble up and actually shade it by scribbling, we're just going to draw a little arrow saying, hey, all the points on this side of the line, but not including the ones on the line, are solutions. The points on the opposite side are not. And that's how we graph inequalities. Again, it's graphing the boundary line, deciding how to connect a boundary line. Is it a dotted line where the points are included, or a dotted line where the points are not included as solutions, or a solid line where they are included? And lastly, we shade. 3 easy steps. Okay, I hope that helps. If you have any more questions, please jot them down and I'll answer them in class.